Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So in today's daily challenge on Leetcode, I will show you two approaches, both using Bitmask and both will be accepted. First will be the brute force solution, the brute force or recursive solution. And the second will be nothing but the optimized version of this using DP or memoization. And stay till the end of the video, okay? And then only I think you will be able to understand. Then otherwise it is a really difficult problem. And I am also teaching DP from very basics to advanced in one of my playlists. Okay, so you can follow the playlist if you are struggling in DP problems. So you can find that playlist link of the playlist in the description. So let's move to the question quickly. In this question we are given n players, okay, 1 to n, and they will compete with each other in the way the one gets compete with the first player gets competed with the last player, the second player gets matched with the second last player, and so on. In this way they compete with each other, and you are given two immortal players, okay, the first immortal and the second immortal players. These two players always win against every other players, but it is not sure what will happen when they both will meet. Okay, so you need to tell that as the rounds progress by, what is the minimum round and the maximum round in which the two players can meet. If you did not understand, take this example. Okay, n is 11. The two immortal players are player number 2 and player number 4. So in the first round, you see the players are something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are the player numbers where 2 and 4 is immortal. Okay, 2 and 4 is immortal. So if you see, if one competes against 11, let's say we proceed in the way like one competes against 11, okay, and 11 wins, and two competes against the corresponding 10, two wins, and three compete against his corresponding player, three wins, and so on. If there is an odd player, the middle player will always win. It is given in the question. And you see the second round status is something like this. Still 2 and 4 have not fought with each other. And in the third round, let's say the first half of the player wins against all of the other half, then they will be remaining. And now you see in the third round who gets competed with 4. So you see this is the earliest possible in which 2 and 4 gets competed against each other. And another possible scenario is which leads to the latest round number is that latest means at the last round number. Okay, this means last. So you see what will happen if 11 did not win in the first round, then the first half completely wins. You see the result of the first round is something like 1, 2, 3, 4, 5, 6. They beat all their corresponding players, and the third round result is something like 1, 2, and 4. 4 can beat always the opponent player, so 4 will win in this case. And you see in the if still in the third round 1, 2, and 4 are not competed against each other, 1 and 4 get completed and 4 wins, and in the fourth round only 2 and 4 gets to match up. They only get to match up in the fourth round. So this will be a very confusing problem if you try to find some greedy method to solve it. Okay, if you try to find some greedy method or you try to formulate some algorithm, it will be very difficult. Okay, so try to simulate this whole um, tournament. Okay, this whole tournament you try to simulate this using Bitmasks. Okay, so how will you know that you need to use Bitmask? The first thing is that you see, look at the constraint. This is always a hint. This is always a hint to use Bitmask because n is 28. Okay, and you know something like 2 to the power 20 is what? 1 is 6. To 2 to the power 28, many times it works. Many times it works. Okay, now it is in the edge case definitely, but it many times it does work. And if you see there are n players, so actually there will be in, in every round the player gets halved, right? Every round the player gets halved. So you actually need to maintain 14, not n, not 28. You need to maintain 14 such bits. So if you see a brute force solution, if you try to do it using Bitmask, will definitely work. It will definitely work. So so that's what we will try to visualize how. Okay, so first of all, by looking at the constraint and also the nature of the problem, you do realize that it has something to do with Bitmasks. Okay, so now once you get to understand some hint, you try to formulate that how can I possibly represent the status of each round using Bitmask. So what can you do? What can you now do exactly? A very obvious way to do that will be to do something like mark 1 if the player is alive and mark 0 if the player is dead. Okay, if the player is knocked out, or I will take for alive or dead. Okay, so initially what happens? Initially, can you tell me that initially there are n players, right? So initially all are alive. Okay, so you can place n ones. Okay, so this can be your mask. Okay, now you are trying to formulate every possible round. You are trying to formulate every possible round. So you know that this player gets competed with this player always. Okay, what if now let's say in after round one, some players are alive and some players are dead. Okay, so you see again this. Now what will happen? This gets competed with this, but 0 cannot get competed with 1, right? Because this is dead. So we will keep iterating unless we find a 1, and that one will get competed with this. Okay, so you also get some hint what to use here. You also get some hint to use a 2-pointer approach here. Okay, so let's take 2 pointers I and j, and I will initially point to, let's say, the index. Okay, so let's say this is 0, and j, let's say it points to index number n minus 1. Now every round I and j, this is of the length very limited, right? This is of very limited length. It's 28. And if you see after every round, it gets halved. The number of players gets halved. So you see, at max 2 to the power 5, at max 5 rounds can take place. So in every round, you can simulate the whole thing. Okay, in every round, you just simulate the whole thing. So you see, I hope you are understanding some things now. Now, what if you need to have some player, the player immortal players? Let us mark that by first player and the second player. Let's say they are present somewhere. Okay. So what we do, we iterate I, and we move I plus 1, and we move j minus 1. Okay, what are the possible cases which can happen? What are the possible cases which can happen? First case which can happen is that I is equals to f. Then j will always die. This is case 1. J will always die. Then we need to off the bit of the bit mask. Okay, we need to set the bit to low. Okay, what will happen if I is equal to first, or I equal to second? You know that, or this happens, you know that j dies. Okay, now what if j is equals to first, or j is equal to second? J is one of those players. Then you see I will die. Let's say this is the case. Now what if both are first and second players? The thing which comes to your mind next is that what if I is equals to let's say the first player, and j is the second player? Then you update you keep some maximum and minimum variable as your global values, and you update them. You just update them. Okay, how will you update them? You know how to update maximum, right? You do max of maximum value comma something round. Okay, you also keep a round number. In every case you just iterate. So there are few more things which you need to check. Okay, few more things which you need to check. What will signify that a round is ended? How will we know? How to know round has ended? Round has ended. Okay, so you see, what was our method of actually simulating the round? We have some ones and zeros. Okay, and we are simulating the round by starting from these. Okay, you see, I is this, j is this. We try to pair these players and see which way wins. Okay, we try to pair these two players and see which wins, and accordingly we increment I or decrement j. Okay, these things you understood. But what if this I is always less than j in that case? But when I becomes greater than or equal to j, it signifies that matching up or matching up for this round is complete. Matching for current round is over. Current round is over. So the next round begins. So how will we understand that the next round has begun? We will understand when I is greater than or equal to j. Next round has begun. Okay. Now, what will we do when we encounter some zero? What will we do when we encounter some zero? Thing is that when we encounter some zero, we will simply increment that pointer. Okay, so if I is encountering a zero, if I is, let's say, encountering some zero, then increment I. If j is encountering zero, then decrement j. These are few observations which you need to keep in mind while writing the recursive brute force solution. Okay, so you see, I hope you understand, right? So I will tell you some things about bit masks. Okay, how do you check whether the ith bit is set or not? Okay, so I will tell you some methods by which you can actually check in a mask. Okay, so I hope you know all this because these are very important things in Bitmarks. So I am assuming you don't know, but so I will teach you some basic Bitmask concepts. Okay. So how will you check whether the ith bit is set or not? So you will do something like mask. You have a mask and one right shift I. It will say whether the ith bit is set or not. So what does this mean? What does this mean? So if you have something like zero, you have some mask. Okay, you have some mask. And let's say you are going to do something like I equals to 2. This is 0, this is 1, this is 2, this is 3, this is 4, this is 5. Now you do this is one left shift I. Okay, so you left shift I 2 times. You get something like this 1 0 0. This is nothing, I equals to 2, right? So you left shift 1 I times. Okay, so earlier it was 1, then you left shift it 2 times. You get something like 1 0 0. Now 1 0 0, if you try to AND this 1 0 0 with this and the whole thing is 0 0, what will you get? These two operations, if you try to AND, you will get nothing but 1. Okay, you will get nothing but 1. So if this is equals to 1, it means that ith bit is set. Okay, so I hope you got to understand this thing, is that if this means that if ith bit is set, ith bit is set, this is the method to check whether the ith bit is set or not. Okay, now how to turn off the ith bit? How to turn off the ith bit? Okay, that we do using mask XOR 1 left shift I hope you easily understand these two also, right? Because XOR, why we are doing XOR? Because if you XOR 1 with 0, you will get 1. If you perform a XOR of 1 with 0, you get 1. If you perform a XOR of 1 with 1, you get 0. Okay, so what do you think? What do you think will happen exactly here? If you want to turn off the ith bit, so one goes to, okay, so let's say you are having some mask of something like this. Okay, and you want to turn off this bit, you want to turn off this bit. So what will you do? What will you do? You left shift this 3 times. This is because this is the third bit, 0 1 2 3. This is the third bit. You left shift it 3 times, you get this something like this. This is nothing but one left shift I, and you perform a XOR. Okay, and you perform a XOR. What do you do if you perform a XOR? Zero. If you XOR 0 with anything, it will remain as it is. Okay, it will remain as it is. And if you XOR with 1, it will change the state. So it will turn this bit off. So okay, so I hope you now understand what do I mean by this. This thing is used to turn off the ith bit. If you don't know, I'm just telling you the theories of bitmask also, which we'll be using in this problem. So this turns off ith bit. Okay, so while I code, please do not ask me that what did I do this, why did I do this, because I just told you how exactly these things are happening. So these two things we will be using, and I hope you got to understand some intuition of how this will work. So let's try to quickly code this question. Okay, so uh, let's try to. I told you that I will write a recursive function, right? So what are the states? What do you need exactly in this function? You need the round number. That is very important because that is something which you need to calculate, right? And you will have some minimum and maximum values. Maximum, let's keep it int min because I am maximizing it. Minimum global value, let's keep it int max because I am minimizing it. So I will keep these things, and let's keep some more things. Let's keep this n0, f0, and s0. This is nothing but the first player, second player, and n player in a total number of round on the basis of zero based indexing. Okay, zero based indexing. So I'm using a global value so that I can use it in all my recursive functions because these are anyways fixed. The first player, which is these immortal players, are already fixed, right? So why want to use them in my zero based indexing. Okay, so how will I do that? How will I do that? If you try to see, I will do something like n equals to nothing but n minus 1. I will also do f equals to nothing but this first player minus 1. This s is again nothing but second player minus 1. So these are in the one based indexing. I'm just converting into the zero based indexing. I hope you understand this easily. So I want to now calculate something. I will just to calculate something. That calculate function will change my minimum and maximum value, and I can just easily return something like minimum comma maximum. I hope you understand this. Okay. Now, what will be required in this? We will definitely require some mask. Okay. So, can you tell me what will be the mask? What will be the mask? So, first thing, we will require a mask. As I told you, we will require an I and j pointer. I and j pointer. Okay, I and j pointer. So and round, okay, number of rounds. So you keep the round also. Okay, so let me keep it in the second argument, just like that. Okay. So initially, what is the mask initially? All ones. So in number of ones. So you see how to write all ones. If you want to do something like 3 ones, this is nothing but 7. This is nothing but 2 to the power 3 minus 1. So for 3 ones, you do 2 to the power 3 minus 1. You get 3 ones. Okay. So what if you need n ones? What if you need n ones? You do 2 to the power n minus 1, and 2 to the power n is nothing but 2 to the power n. You know this, nothing but 1 left shift n. Okay. So how to set up initial mask? I guess you understand that. My initial mask is nothing but 1 left shift of n minus 1. Okay, this is the total number of the round. This is the total number of players. I hope you understand this. Initially, round 1 is going on, so 1 we pass it, and it is quite obvious that I and j are initially 0 and n minus 1. Okay, this is I is initially 0 and j is initially n minus 1. So I put I as 0 and j as n minus 1. And I hope you get this. I hope you get this easily. And all we need to write is this void calc function, which will not return any value, but it will modify this maximum and minimal global variables. So I have my mask. Okay, I have my round. I have my what's it called? It's called first player, immortal player. I have the second immortal player. Okay. Okay. So now you see what we do is very simple. Uh, I try to do the first thing is that how will we know that the round is over? We need to start a round. The first thing which comes to your mind is that we need to start a round. And in order to start a round, this thing must be valid. Okay, this thing must be valid. So if if it is something like I greater than or equals to j, then you do start a new round. So how do you start a new round? You keep the same mask. Okay, you keep the same mask, you increment the round. Okay, and you reset your first I and j value. So I did not if you notice that I did not check the I and j. This will be I and j values, right? Why will this be f and s? F and s is stored in the global variable. Okay, so this is not f and s, this is just I and j. So if I is greater than equal to j, these things will be as it is. These things will be as it is. Not as it is, it will be reset to 0 and capital N. I hope you understand this, right? So as we are starting a new round, uh, we need to reset the pointer, right? In every round, we just complete the corresponding players. We just complete it. okay, with each other, and I and j gets iterated. And when I is this happens, we start a new round, we set the I to 0 again and j to n minus 1 again. So we are just resetting our points. Okay, in each round I am just incrementing round, increment round, and reset pointers. Okay, so this is very simple if I is less than equal to. Now, what if you need to do some things when you are starting up with the round? So the basic things, the most basic thing, what do you observe? If there is a 0, you increment the I. Okay, you increment the I, and if there is a ith bit, so what do you ask? What do you ask? If you see, you take the mask, you end it with ith bit. Okay, so this represent if the ith bit is set. Okay, so if you catch the ith bit and check if it is 0. Okay, you catch the ith bit and check if it is 0, then you get to know that this bit is off, right? So this checks whether the ith bit is set. You This finds the ith bit basically. Okay, so you just checks whether the ith bit is off. Okay, then what do you need to do? uh, you are in the same round. What you will do is very simple. You just increment your I and keep the j same. I hope you understand this, right? If there is 0, you just increment I. And what if j is 0? Now you can ask me that what if j is 0? So you will get something very similar to this. If But here j will be there. So if j is 0, you can do something which is very simple. You can just go for ij plus 1, okay, j minus 1. So if j is 0, you are decrementing j because j is the right pointer, right? J is the right pointer. Now, else if there are more conditions you need to take care of. Now, what if the first pointer I is nothing but the first pointer and j is nothing but the second pointer? What if this is true? What if this is true? Then calculate. You don't need to calculate anything. You see, now the immortal players are coming head to head. So you need to update the maximum and the minimum value. You need to do nothing but update the maximum and the minimum value with the round. That is what we need to return, right? That is what we need to return. So you see, now we got the base case. These are nothing but the base cases, right? These all were nothing but the base cases of the recursion. You can think it like way, okay, like that. So you might call that why in the base case we are again calling the function, because that is the 0 case, right? Which we just want to go ahead. So whatever be the thing, I am just telling that this thing. So what does this thing mean? That the top best player comes head to head. Okay, this just simply means this. Okay, now you can tell me that what if I is the immortal one? So if I is first or I is second. Okay, so if I is the immortal one, what will happen? What will happen? J will die. Okay, if I is immortal, J will die. So I need to off the jth bit. I need to make the jth bit convert. It means that convert jth bit to 0, or you need to off the jth bit. Okay. Uh, so it is clear, I guess. It is very clear now. So what we do is very simple. You turn off the jth bit in the mask. So you perform a XOR operation. Okay, you just perform a XOR operation, and you turn off the jth bit. I hope you easily understood why I am doing a XOR. I have already told you in the theory. So after this, I get incremented and j gets decremented. I hope you understand this. One round is complete, so definitely that will take place. What if, now you can ask me, what if j is the immortal one? Okay, what if j is the immortal one? So you can tell me that if j is the immortal one, I will do something very similar. I will tell that I dies. Okay, I will tell that I will die and convert the ith bit to 0. That is, turn off the ith bit. So uh, all I need to do is turn off the ith bit. Else, you can tell me that else what will happen. What will happen if none of this is true? It means that I is not the immortal, J is not the immortal. Can you tell me what will then happen? What will then happen? It is very intuitive to know that you can try both ways. We can try first. I can die, J can die, both of them can die, right? So I will kill J first, or anything, right? Anything I will do. I will kill I first and J second. Okay. So I hope you understand this. This means that anyone can die. Anyone can die. Just go through both of them. I just go through both of the variations. So do you think we are done actually? So let's try to run this code and check if there are any errors or not. You see, we are getting accepted. Let's try to submit it and check if it actually works. So according to our calculation, there can be at max 5 rounds, right? Okay. So only 5 times we are simulating. So I don't think we are doing anything bigger, even if uh, I mean, even if you are doing something like brute force. Okay. So only 5 times the round will happen, and we can easily simulate using a recursive function. Now you can tell me, can we memorize it? Can we use DP here? Definitely we can. Definitely we can. Okay. Instead of all this fuss, can you try to tell me some very, I mean, clever way of shrinking the code down? Okay, so because unnecessarily the code is becoming very big with a lot of else if, else if, else if. So this is looks very unattractive. Okay, this looks really unattractive. So what I can do, you just tell me if this is fine. I am writing something. I am writing something. If I is not the first one and I is not the second one, okay, I is not immortal, then you can kill J. If I do not write else here, if he is not the first one and J is neither the second one, you can kill I. Do you think this will suffice every time? Now try to run it. Try to run it in your mind. Okay. You try to run it in your mind. So what if I is immortal? This is false. Okay. What if I is immortal? Okay, so if I is not immortal, you can kill I. I just did a mistake here. You can kill I and J. Okay. So what you try to run? What if I is F? What if I is F? Then it will not go inside this loop. It will automatically go inside this loop and kill J. Okay. What if I is S? Then again it will kill J. What if I is what if now J is F? If J is F, this if statement will not be valid. This statement will get valid automatically and it will kill I. Now, if both of them is not F or S, then both of these statements are true. If both of them is not the first one, not the second one, then this both of the calc statement will get valid. So you see, this is a hack, you can say. This is a shorthand, you can say, of doing this. We do not need any other conditions. So you can just try to run it and check. You see, we get the accepted thing again. We do not need to check again and again, right? Uh, you can just try out this hack. Okay, so whatever be the case, this also works. But now, how do I memorize it? How do I do the DP? Now, the thing which you need to be careful here is that uh, what are the states of the DP? What can be the states of the DP? You see, what is mattering here is that how many players. So you can visualize it. It's something, right? This is okay. I will agree that this is very difficult to come up with, but you can try to visualize it. Something like this: you are having a mask. First player, let's say the first player and the second player, these two immortal players, when they will meet up, this depends on how many players are here, how many players are in between them, how many players are to the right. These are the states which actually matter in determining whether these first and second players will meet. So why don't we call as the number of players before F as L, number of players between F and S as M, number of players after S as R. These three states can be the states of the DP. These three states can be the states of the DP. And all we need to do in this is that we need to check whether this whether we have already visited or not, whether we have already visited a particular state or not. So we will initialize the whole dpy minus 1, and if it is visited I can just mark it 1. Okay, I can just mark it 1, and we can do a very similar to what is done in memoization. Okay, so but you need to change this l, m and r very carefully. You need to change it very very carefully. Okay, so how will you change it? So first you take L, M, and R. Okay. So take three variables. L, M, R. Okay. L, M, R. But what are these? What are the initial values of these variables? The first, the number of players before the first player. Okay. So what is that? That is nothing but first player minus 1, which is F. Now number of players in the between is nothing but second minus F and minus 1. And number of players at the last is nothing but this n minus s. Okay, so you can I am using the one based indexing for all of this, row based indexing for all of this. So you can just check that these are the number of players in between them, before them, and after them. Okay, so I get something like int l, int m, and int r. Okay, these are the number of players in between. Before, l represents before, m represents in between, and r represents after row. Okay, so you see, these remain same, right? L, M, and R does not need to change when the round is resetting. L, M, and R does not need to change when we are just doing the base cases. Okay, these are not the trivial base cases, but these are base cases in a way if you look. Okay, so the thing which you need to see is that we need to restrict the entry only to this else loop. Okay, so I will do something like, first of all, I can set up a DP, okay, with these three things. So I will set up something like 27, 27, 27. Okay, so I just set up the DP and I initialize the whole DP to minus 1. So I do meme set of DP minus 1 size of DP. Okay, I hope you understood this. I hope you easily understood this, right? So you get it now. And you need to change this L, M, and R also, right? You need to change this L, M, and R. How will they get changed? You need to think it very carefully. In every round, one player dies. Just one player dies. Not in every round, like in every matching, when I and J are there, in every matching, one player dies. Which is that player? How will you determine that? So you can check. You can check. Let's try to visualize this now. Uh, you have the first player here, you have the second player here. Okay, you are, let's say I is dying, the case where I is dying. Okay, you, in this case the I is getting died. Okay, so when I is dying, if I is less than first, then L gets decremented. If I is greater than first, so if I is something greater than first and I is less than S, then M is getting decremented. One player from M dies out. Now you check if I was here, or if I was here, or now if I is something greater than S, then R value get decremented. So I hope you understood what we need to do here is very simple. We decrement L by 1 only if this I value, the guy who is dying, is he less than F, then only we decrement L. Okay, now we decrement M only if the guy who is dying is greater than F and is less than S. I hope you get it right. We can decrement R only if the guy who is dying is present after S. Okay, the same thing, you can do the exact same thing, just you do The guy who is dying is J. In the next case, you can do the exact same thing, but the guy who is dying is J. Okay. So I hope you understand, right? I hope you easily understand this. Now, I need to memorize, right? So this, I told you that these are sort of the base cases, and these are only the cases where L, M, and are getting modified. In these cases, L, M, and are not getting modified. So you do not need to change the state of the DP. You need to perform them every time. Okay. You can save the state only if L, M, and R are getting modified. Those are the states of the DP. So you just check that if DP of L, M, and R, if it is equals to -1, okay, then only you can do this, and otherwise you just change if it is not visited. Okay, otherwise you mark as 1 by telling that if it is visited. Okay, this date is visited, and this says that do not enter if date is unvisited. If enter Do not enter if state is visited. Okay, so uh, I hope you understand this, right? I hope you now get it actually. Uh, do you think we will be able to do anything better? First of all, let us check if this works, or this gives a TLE or some wrong answer. So let us just check it whether this will work. So see, it works and it is performing the best. It is performing the best with 100% bits. So I hope you easily understand this. This second DP method is definitely not an easy thing to come up with, but you just keep practicing. You just keep practicing, and things will just happen automatically. So I hope you were able to understand this whole approach. If you have not, you can comment the timestamp of whatever portion of my video was doubtful. You can just comment the timestamp. So yeah, that's all for this video, and I hope your day goes really easy, not as hard as this problem. Thank you so much.